So okay, today we are going to solve some problem. I guess you will get some idea. So did you completed all the videos? Because I think we are more than 50%. This is 8, the remaining 4, and we are going to finish this course. Yes, hello, good evening, good evening. Did you completed all the videos? Not all. Okay, then we will let me charge my phone for some time. Do you have any doubts? Then you can ask any specific doubt, anything you want to ask. Then we will. But my phone is charging right now. So it will. We can discuss for some time. This is a question that we are going to solve. Consider the image given in the figure below. The mesh contains 2 Kirchhoff plate bending element. Number inside circle indicate element numbers. While the first we will see that image. So this one. This is the image that he was talking about. 1, 2, 3, 4, 5, 6. Okay. At each node, the number of degree of freedom must be in sequence of W del y by del x, del y by del W by del y, where W is the deflection along Z direction. Okay. The plate deform under certain loading such that all the degree of freedom at node 1, 2, 3, 4 are 0 and at node 5, 6 are given by. Okay. At node 5, minus 0.1, minus 0.02, minus 0.02. At node 6, minus 0.2, minus 0.04, minus 0.03. Assume thickness of the element 100 mm. Provide following value in the sequence. Values of shape function n1 and n3 at point this for element 1. Value of function n1 and n3 at point at 1.50, 3 at element 2. Strain component EXX, EYY, EYZ evaluated at the midpoint. Okay, just this is very long question, and so now you have to try this question, but my phone is going to charge. Let me take my pen. What they are saying. This is one of the element. Okay, element 1 and 2. Node 1, node 2, node 3, node 4, node 5, node 6. So we are having total 6 elements, and this element have this node 1 having coordinate 0, 0, node 2 1, 0, then node 6 having 2, 1, then node 3 having will be 2, 0. This is by 1. This will be 1, 1. This will be 0, 1. Yeah. Yes. So this is the element, and that we have to find so many things. I will just copy this one from here and paste here. Now again I will read question. Consider the mesh given in the figure below. Okay, this is the one of the mesh. The mesh contains 2 kg plate bending element. Okay, number inside circle indicate element number. Okay, so this is the element 1. This one is the element 2. We are having 2 elements. Fine. Then it's okay. We are having 2 elements. At each node, okay, number circle indicate element number, while the number next to the filled dot indicate node number. Okay, so node 1, node 2, I will write here. So total element, how many total elements we are having? 2 elements. Total nodes equal to 6. That's fine. At each node, the numbering of degree of freedom must be in the sequence of W, W dash, W bar, W dash, W del by del. Okay. W is the deflection along Z direction. That's fine. The plate deform under certain loading such that all the degree of freedom at node 1, 2, 3, 4. So node 1, 2, 3, 4 are 0. So degree of freedom at node 1, 2, 3 and 4 equal to 0, and degree of freedom at 5 and 6 given by this. Yes. Okay. So like each node having 3 degree of freedom. Okay. This one. Each node this one point we taken. So each node having 3 degree of freedom. Yeah. Assume thickness. Okay, we have to assume thickness of element 100 mm. Provide the following value in the sequence. Okay. First, N1 and N3 we have to find. N1 and N3. Are you here? So, do you have any idea how we are going to solve this problem? Kirchhoff element. and I have to find that Kirchhoff element PDF. Okay, then how we can start? So actually we have to find shape function n1 and n3. So for Kirchhoff element, we are having predefined, like we already drive everything. If you go through video, you will get to know that how to drive shear function for Kirchhoff that element, or Kirchhoff plate bending element. Kirchhoff plate bending element. If you will go through video, so like I already have this solution of this problem. So how we are going to do? So what is interpolating polynomial? For this Kirchhoff element, we are having interpolating polynomial like y equal to, because we are having x and y. So this is 2D element. So this is x, this is y. So our shape function will be in term of x and y. Yes, right. Yeah, that one I know. So like but I think I can wait 1 minute. I have to download the Netflix. Okay. Here I can download. I guess you go through that all the plate element, but anyway, I will try to explain as much as I can. This okay. So, okay, this. Okay, finite element modeling theory. So, okay, like first I will take few page. I will add some pages here. Insert page. Eight. Okay. So first I will give a little bit intro. What is actually Kirchhoff finite element? That Kirchhoff element. So we will start with that Kirchhoff theory. Hello? Are you here? Yes. So what should I start? Should I start solving that problem, or should I give a little bit intro about what is Kirchhoff theory? Hmm? Okay. So I will give you like overall, then you will go through all the videos and you will get like in depth. So what is a finite element modeling? Finite element modeling for thin plate. Thin plate. Okay. What is actually this one? That's we are having XY plate means it is in 2D direction, like 2D frame. This is our 2D frame. This is Y. This is X, and we are having this is a double plate. This is our okay, chassis plane. This is one of the plate. So this is having coordinate. This is x1, y1. This one will be x2 and y2. Okay, so it is having how many nodes? It is having total 4 nodes. So node 1, or I will use other pen for writing node like this. See blue one. Okay, this one. So node 1, node 2, node 3, node 4. It is having total how many nodes? 4 nodes. Okay, and each node is having 3 degrees of freedom. Each node have 3 degrees of freedom. 3 degrees of freedom. Okay, which one? Like W del W by del X, then del W by del Y. Okay. So okay, so how many total we are having? Total 3 degrees of freedom, and each node having that we are having total 3 degree. Each node total we are having 4 node, and each node having 3 degrees of freedom. So total 3 cross 4. 3 3 cross 4 will be 12. Totality will be 12 expression. So in like in normal displacement, so like if I will write in normal or general displacement, there will be total 12 times. कैसे? अभी वो Pascal triangle, okay, so did you heard about that Pascal triangle? So according to that triangle, how we can write? So W x comma y will be that a naught plus a1x plus a2y plus a3 square plus a4xy plus a5y square plus a6 x cube, then a7 x square y plus a8 xy square plus a9 y cube plus a10 x cube y plus a11 xy cube. So these are the total 12 times for the general displacement for this 2D plate. We are calling that Kirchhoff plate. I think you are not getting what actually I was talking about, so I will that Pascal triangle. Hmm. 12. Yes, that we know. How we are writing this Pascal triangle? Like we are writing in this way. If we are starting with 1, then 1, then x, y, then x square, xy, y square, then x cube, x square by y cube, then x4 x cube by x square by square x by cube, then by 4. So like total we have to maintain that power. So like it is having 1, then it is having 2. Total power here we are having how many? This is 1. So this is 1. This is also 1. This is having 2. This is also having total power 2. Then this one 3, 4, 4, 4, 4, 4. So total power we have to maintain. So like how we are going to write them? This one will be for constant. This is linear. This one for quadratic. Then this will be for cubic. This will be for quadratic. 4, 4. Yes, I think you know this one. I just went a little fast because this is not that much tough. Yes, no. Yes. So now what we are doing? Now what we have to do. So we got this general displacement time. This one we got here. This one. But what we have to do, we need to find that shape function for each node or node 3 or 5. That one we have to do. So by using this one, we are going to find that shape function. Okay. Okay, this is all the fine. How to find shape function then? Like we are having very big derivation. But directly I will go to formula because it will take so much time. Okay, so now we got this expression. I think now you have little bit idea what is actually internal displacement. So now we will go to our problem. This is our problem. So but interpolating function, this is our displacement that I told you. This is our displacement that we got. Okay, so A node, A1, A2, A3, all these are the constant. All these are the constant and x, y are the variable, then x and y direction because this is our 2D element. Now, so now we have to find that this one. We are having 3 degree of freedom. So first we got W. Now I want to find del W by del X. So okay. So just differentiate this W with respect to X. So what you will get here. See, if we are doing with respect to X, so we will get X only A1, then 2A2, 2A3, this one will become 0, so 2A3 X plus A4Y plus 3A6 X square, then 2A7 X, 2A7 XY, yes. Then it will be A at Y square, then it will be 3A10. Okay, then what I will write here, speaking then. So now I want to find del W by del X. So del W by del X I want to find. So I just copy this one from here. This one I can copy easily. Copy. चलो नीचे paste. नहीं लिख देता हूँ. I will look for this one. then paste here, paste. Okay. So now I want to find del w by del x. So del w by del x, what will it become? It will be 0. It will be a1 plus 2a3x plus a4 by plus 3a6x square plus 2a7x by plus a8 by square plus 3a10 x square by plus a11 a11 by q. Okay, then I want to find del w by del y, then it will be a2 plus a4x plus 2 a5 by plus a7x plus 2 a8x by plus 3 a9 by square plus a10 x cube plus 3 a11 x by square. Yeah, this is correct. Okay, please look like correct only. Yeah, this is correct. Can you just verify once? Del w by del x, del w by del y.
Sir,
Hmm.
sir, sir, that the del w by del y is like so a7x square, no, sir?
AC1 x where? This one, this one.
Yes,
Yes.
sir, yes, sir.
Yes. This is A7 x. Sorry. Rest of thing okay now?
Yes, sir, yes, sir.
So now we got this del w by del x, del okay, that we got, that's fine, fine, fine. So I will just take this one from here and copy, and we will go here and we will check what actually going here. So I will just copy paste this one. We also can verify, we also getting same, so that's fine. So now we got this, we got del x by del y, and 1 minute. Oh, sorry for disturbance. I got one important call. So we got this. What we got? We got del by del x. So del w by del x and del w by del y. Actually, this is written. I have not seen that code. So, but anyway. So now after calculating the so we got all 3 degrees of freedom. This is w by okay. We have a 3 degrees of freedom. W del w by del x and del w by del y. Okay, these 3 degrees of freedom. So we got first one, second one, or this is our third one. Okay, that's fine. Now what we have to do? Now we are going to find the shape function. Shape function we are going to find. How you wrote this shape function in matrix form. Then I have to explain again everything. Actually, like without this base, very difficult for me also to explain each and every term. But anyway, I will try to manage somehow. So this we got, this one we got. Okay, okay. One more thing. So did you start using your MATLAB or some other thing for the coding structure analysis? Hmm? So are you planning for any post like placement or for higher degree? Because if you are planning for higher degree, because without FEM, like without coding, we cannot learn structure dynamics or finite element. It name itself finite element. So we have to write some code or like something. I'm not able to find the derivation. Okay, so just I will go through and like if next class if you have any question, then you will let me know. So how to find the shape function? So we are having that formula in matrix form. If I will write in matrix form, it will look like uh, P P x comma y equal to 1 comma x comma y, which is the similar thing we have to write here. So this will be our interpolating polynomial. Then what will be del p by del x? So del p by del x equal to, in text form it will be 0 1, okay, 0 1, then 2x, then by, then 0, then 3x square, then 2x by, then by square, then by q, then xq, sorry, it will be 3x square by, then it will be by q. It will be like this. And with respect to by, so del p by del y equal to, del p by del y equal to, what will be, then it will be 0 0 1 0 x 2 by 0 x square 2x by 3 y square x cube 3x by square. It will be like this. And now coordinate for element 1. So we already define here coordinate for element 1. So this is element 1. This one, this is our element 1. This is our element 1. So x1 by 1 for element 1 0 0 comma 0. Then x2 by 2 1 0. Then this is x3, this is x4. For first element, for second element, x1 by 1 x2 x3. Okay. So now we are going to write this in this form. So for first element, we are solving for first element number 1. For element number 1. So this is our element number 1. Like total we are having 2 elements, element 1, element 2. This is node 1, node 2, node 3, node 4, 5, 6. And one thing we have to remember for this type of element, that mapping we have to like do. So this will be like 1 2, okay, 1 2 1 2 1 2 2 2 3 2 5. Did wrong. 1 2 3 5 1 2 4 1 2 4 5. 1 1 3 2 5. गलत लिखा है. Don't go through. So for x1 by 1 x1 by 1, then x1 by 1 x1 equal to 0, then x2 equal to 1, x4 equal to 0, okay, then by 1 equal to 0, by 2 equal to 0, x3 equal to 1, then by 1 equal to 1. So actually this for all, for element 1, so this will be x1 x, so this will be x1 by 1 x2 by 2, then this x3 by 3 and x4 by 4. Yes, right. So we got x1 equal to 0, by 1 equal to 0, x2 equal to 1, by 2 equal to 0. Are you getting something, or I'm just speaking? Because this is little bit like difficult to understand once, but it will require a lot of practice and what we call experience, like not experience, like it is require a lot of practice and revision. Then by 3 equal to 1, x4 equal to 0, 5 something. Okay, that's good. So this is our, these are our final element, that coordinate we got. That's fine. Oh, what is this matrix? Sure. Yes. So what is the C1 matrix? C1 matrix is the matrix that contain this is del P at like for example, this is P at x1 y1, then del P by del x at x1 y1, del P by del y at x1 y1. Similarly, at x2 by 2, x3 by 3, x3 by. So I will write in this like this. So C1 equal to C1 is the that derivative of shape function. So uh, C1 equal to P at x1 by 1. Okay. Then dp by ds at x1 by 1. Then dp by dy at x1 by 1. So how many nodes we are having? We are having total 4 nodes for first element. So it will be we have to write 4 times. So it will be for similar for p x2 by 2 and dp by dx x2 by 2. These are in a row, yaar. It's right now. Yes. This will be comma comma. Similarly for dp by dy x2 by 2, then p x3 by 3, then similarly for x3 by 3, x3 by 3, then p x4 by 4, similarly for this fourth element. So now what will be p at x1 by 1? So but we are having p, it is p. So this is our p. This is our p. It is having 8 element. No, it is having 12 element. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, total 12 element. Because we are having that our displacement function having 12 element. Here, yeah, this one. 1, 2, 3, 4, total 11, and this is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, total 12. Correct. Going well. So now, so this is the for this element. How many we are having? Uh, element. 12 element. Okay, I will write here. 12 element. Similarly for this one, 12 element. So all are having 12. So first we will write this one for. So we first whatever we are having x1 y1 0. This is our 0 0 comma 0. And if I will put 0 comma 0 in this function here, so all these will become 0. All these will become 0. Only one remain because this is constant. Only one will be remain here. So we got one here only. Now similarly, del p by del, then del p by del x 0 comma 0. Okay. So del p by del x again. So this one. So these all will become 0. Then again one will be here. Are you getting right? Yes. You can say yes or no, something so that confuse a little bit. Where you will get confused, I will try to rectify. Just tell me.
So this part only I got confused. So whichever you're rubbing it.
This one, na?
Yes, sir. Yes, sir.
Wait, then other things okay?
Yes, sir.
I will start again from here. So this is our C1 matrix. See the matrix that contain that our P del P by del X and del P by or sorry not del dP by dx, dP by dx and dP by dy. So this is 3 term, and these 3 term we have to find for all node. At each node we are having total 4 node for this element. Okay, so like for this one for 1, 2, 3. So for this is for first node. So these 3 are for first node, node 1. This is for node 2. This is for node 3. This is for node 4. I think this is correct. This is fine. So for node, we are having total 4 nodes. So first, first this expression will calculate node 1, node 2, node 3, node 4. Okay, that's fine. So this is having total how many element? Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. 1, 2, 3, 4. It will be total 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 3, 11. Yes. It is having total 12 element. Why 12 element? Because from starting we are having 12 element of our displacement function. That is fine. So this is written in the in a what we call. Like I will write 1, 2, 3, 4. So in the row form. Okay, and each row having 8 element, each row having 12 element, because this is 12 by 12. This is having 12 element, 12 cross, or I will say 1 cross 12, because it is having only 1 column. 12 cross 1. So now where you got confused, I will then again I will try to rectify. No confusion.
Sir, till you're now I understood, sir.
I don't think you are got under. I think you got angry why you are not able to explain. But see,
No, sir.
I'm writing in that this is in matrix form. This just one you have to take care. This is in matrix form, so you will not look like simple that I am writing. If you write code, then you will get like yeah, this is in matrix form. So this element itself having 12 element. Sorry, this term itself having 12 element. So each element, each term having 12, 12, 12. That's why this is also 12. This is also 12, 12, 12, 12. And then again each row it will be 12, so total will be 12 cross 12. Okay, see, So how many we are having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 row. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it will be 12 cross 12. So I think that if you remember first class itself, what I told you, I think hopefully remember how many nodes we are having. We are having total for first for one element. So for this is our one element. One element. We are having node 1, 2, 3, 4. We are having total 4 node, and each node having 3 degree of freedom. So what will be size of stiffness matrix? Did you remember that one that time? 4 into 3, it will be 12. Yeah. So that's why we are getting here. How many we are getting? 12 by this will be 12 cross 12. So this rule applicable everywhere. So this will be our final matrix. Hopefully you got. This is our C1 matrix final. This much big expression we got for this one element. And what about if we are doing for two elements combinedly? So that's why like I'm trying to explain this type of question we cannot solve by hand, never ever. Just we have to write our own code and we have to run that simulation in MATLAB, Python, anywhere. So just I'm trying to give you like how we are just at least basics should be clear, then we can go for coding. But we are not able to do how who can write this much big question. Yes, no. I will check your message. If you said no, then I will write. Yes, you said no. So maybe I have to write this equation. So our final equation for
No, sir, no, sir.
I'm
Sir,
just
I've taken the picture also already, sir.
ah. So see, like these question after writing code you will get. If I even though I am not able to remember all the no one going to remember. So the hence the shape function for n1 n3 element will be like this. This is for expression for shape function. Then similarly for element 2, now we are going for element 2 that x1 y1 x3 we all calculate. So this is our element like this we are having element 1, element 2. So the for element 1 it will be x1 y1, it will be x2 by 2, then it will be x3 by 3, then it will be x4 by 4. I don't know exactly that numbering. Yes, so no, this will be one thing you have to remember for this 2D element that numbering should be in order. So like x1 by 1, then it will be x3 by 3, x4 by 4. Yes. So no in 1, 2, this will be 3, this will be 4. So we are having now 4 element. So again we have to start.
Sir,
Hmm.
sir, like we don't have to do it in that clockwise or anti-clockwise way.
No, that not required. I think we have just think how we are writing. That's not required clockwise, anti-clockwise. If I'm going like this, that's okay. But don't go like if you are writing like this, then you are going in this way. The x1, x2, x3, Oh, did I miss anything? Export. Hmm. Yeah, I think I also got confused. So what I was saying? Wait for a minute. I will go to basic. This one I will take. Maybe I also got forgot. I think we have to go through that proper. I'm also not that much intelligent. Somehow I'm trying to manage. Yes. So this is our x1 y1, then x2 by 2. Okay. Then x3. Yeah, this is x3 by 3. Then x4. So in the yes, yeah, we have to go like this. Yeah, it was you are correct. So like we are going anti-clockwise. This one also we went anti-clockwise direction. Yeah, that's correct. So now we have to go through similar thing. Again, we have to find matrix C2, then P1, that P at x1, y1, del P. We already did like this. Just we have to put value and you will get one matrix C2. This will be your matrix C2. Okay. Then shape function N2. This will be your N2. And finally, how will you get this much expression? This big expression you will get for N2. Now, what is the next term? This big question how we can solve. So we got this. Okay. For element 1, element 2, yes, we got. Now we want to find strain component EXX, EYY, and gamma XY. I will take some water. Do you have any doubt as of now? Or you are feeling boring? He also don't know you. Then why you are
No,
teaching?
नो सर, आई एम जस्ट थिंकिंग कि मैं एग्जाम में क्या करूंगी सर, हमेशा वही दिमाग में होता है सर.
No, these type question will not come. ऐसे नहीं आएगा. They will not give this type question. But some like methodology, something, some like small concept, maybe they will ask. But not this type of big question. If they are going to provide, if they are going to give this type of question, then they will allow to write your own code. But by manually, no one can do. No one will remember the type of the big equation. So not that much worry. Or normally we are not doing like this. Like simply going for till beam truss mostly and some basic question from this type of 2D element. Because who will remember this big question equations? So not that much. No, just like uh, see what way that's shape function. Yeah, this equation who will okay. But maybe even though you remember the type of equation, or even though you are able to drive this equation, then itself it will take 1-2 hours, and total exam will be for 3 hours. So one
Yes.
question will take 1-2 hours. Then
Yes,
what's the
sir.
meaning of doing the type of question?
Yes, sir.
So that whoever that designing question, they are also thinking that I'm sitting there and writing that question, I'm writing that answer. So they are also not that much.
Yes, sir.
But like my duty is to like teach you how to how to at least at least I want to tell you how you are going to start some basic of physics so that it will be easy to understand in future. That's my only duty. So give me 5 minutes, I will come back. Okay, 1 minute. I'm just coming. Yes. Yes. So you need some break or we will continue?
Sir, anything, sir.
So if you like, we can take 5 minute break and then okay na?
Yes, sir, anything, yes, sir. Kuch bhi.
And like okay, we will continue. We will finish this question. Okay. So now what we want to find? We want to find strain component EXX, EYY, and gamma XY at the midpoint of element 1, top surface. Okay. At the midpoint, this here we have to find that strain. Okay. Similarly for node 2, here also we have to find. Now how we are going to solve? So we will go again. We already having solution, so just we don't have to worry that much. Yes, this one N2 fine. Now what the this one I think curvature. Now if you go through that video, you will get that how to write this equation. But yes, what is K is the this K is the curvature. curvature. So this is x, y, and gamma x. So then what is that? Let a theta is the, okay, so this is a theta equal to del w by del x in x direction, and theta in y direction, del theta del w by del y, and I means at ith node, at node I. For example, I want to find for at node 4, so 4 node 3, or say 3. So what will be theta? So theta 3 x equal to del w by del x. Okay, then theta 3 equal to del w by del y. Yes. So now after putting, then we have to find what will be this one. Yes. So this big expression I am also getting like. What is strain? I will write strain equal to del in x direction del u by del x in simple word. It will be like this. But in terms of that shape function, we have to write the expression, this big expression. Actually, I'm not going to derive this big equation because it will itself take 2-3 days. So I'm just giving you some hint that how we are going to solve. So that our strain Exx, then Eyy, then gamma xy. By putting the value in this equation, what we will get? We will get like this. This will be our final equation. Then okay, this is the this is not required. B1, B2. So finally we will get B1. This will be our B1 and B2. What is B1? B matrix is the that connect strain stress matrix. Yes, are you getting something? I don't think I'm also not that much like. It's a very big expression and not easy to understand. Anyway, I will upload this PDF and I will go through. Then I think you will get something. NPTEL FEM and CSD. You know, these are two different subjects, FEM and CSD. But we are trying to learn in one subject itself, so it will take a lot of time. So I just want to tell you that please write. Anyway, I will share this that PDF, and please try to write your MATLAB code and solve this problem by using a code that will be easy for you further. Like what I will say, if you are going for higher study, that will be easy for you to write any different code in either MATLAB or Python. This is very important. Without code, it will not be easy to understand. Like, see this big expression. Any other thing you want to ask? I think this question over. Only one question per one. I will find other question. So I think that your lecture number, which lecture number? This will be lecture number. No, week 8. If you go through week 8, you will find all these questions, like all these concept how to derive that elemental equation, that Kirchhoff plate bending element, that shape function and other stuff. In week 8, I think you will get, it will be easy if you go through all the video, and because more than I think 50% we finished, like remaining 4 lecture only, that FEM going to finish, FEM and CSD, and then you have to write your exam. So when is the exam date? I think 28 October, right? Exam date.
Yes, sir.
28 October. So then I think at least 1.5 month, that's it, 45 days remaining. So just try to go through, because these are very, like, this is a little bit difficult also. That this is not as much simple as we are thinking, that only go once and we will get all these things. I took around, for me, it took around, I completed 3 subjects, like 2 subjects for FEM and 1 subject for CSD. Then other one for that structural dynamics. Then after I know that, yeah, something like all are related. First time I was thinking this is different subject and this is different subject. And normally what happened with us, like we are not going through in our UG in that much in depth. So when directly coming for our PG, and we are going, oh, CSD is different and FEM is different. Yes.
Yes, sir.
So what, like we are still having 30 minutes. What we should do? Should we solve any other problem, or should I open my notes? I will open my notes. That will be easy. So you know how to solve the problem for beam and other truss element, right? Huh? Map element. Then I will give you one question. So now this is your question. What question you want to solve? So we are having one 4-node element. This is our 4-node element. By x by x, and this is 4-node element. This is node 1, 2, 3, 4. Node 1 we are having element 5.3 coordinate, 5.3, 4.2. Node 2 having 5.2, 2.3. Node 3 5, 4.2. 5.1.4. Okay, this is one of the 4-node element for direct lag management. Yeah. Yes. You are you sleeping? I'm just trying to find one simple problem. So now you have to find one stiffness, evaluate matrix kx for the quadrilateral element shown in your figure. Assume kx equal to 1 and use 2 cross 2 in the 2 cross 2 integration. Yes, please solve this problem. क्या बोल रहा है रोशन? Hello, can you solve this problem? No, Oh, no, you have to try. At least try something. No is not the answer. This type of question maybe they will ask. Do something, then I will tell you. Like at least write how to get how to write stiffness equation. Because like we are going to finish this course, so okay. One thing I want to ask, like if I want to write stiffness equation for this 2D element, what should I do? Should I do volume integration or should I do area integration?
So we have to find that B matrix and normal, sir.
How?
So we have to find that B matrix and normal, sir.
So I'm just saying like we are having 2D element and I want to find stiffness metric for that element. So what should I do? Should I use volume integration or area integration? Hmm? Did you got my question? Okay, so how we are going to solve this question? First, we have to write equation. So what will be our kx equal to? We are going to use double integration area kx and Bx transpose, then dA. And actually what then this is in terms of our that local coordinate, and we want to convert in isoparametric element, so it will be minus 1 to 1, minus 1 to 1. Then it will be same kx bx transpose, then determinant j, this will be our Jacobian matrix, then ds and dt. Okay, and as I told you, we are going to use 2 cross 2 method, integration method. So now what we have to do, it will be look like summation I equal to 1 to m, number of I equal to then 1, j equal to 1 to n, then wi, that our the 2-point Gauss quadrature rule, it will be then kx bx. Actually this is different, this I will write, this is capital K, this one is the small k that we are having value. Then what will be bx at asi ti tj, then bx si tj, then determinant j at xi tj. Something you have to write, then you will get. This is up to you how I wrote this question, you have to understand, and you have to tell me in next class how should I get, how we are going to get this equation. Then nodal coordinate, we have to write nodal coordinate, okay, and that xa, then by a in matrix form. For point 1, then okay, then we have to calculate all these, del n by del x, del n by del s, del n by del t,